Algebraic formulae are the way that we represent most of our information in maths. Is closely related to a previous video I did called algebraic expressions, but in general, algebraic formulae would refer to the more common equations that we end up seeing in both maths and science, and the ways that we'd solve them, particularly useful in science for when we want to represent information on something like, say, a graph, or rearrange a particular formula to get a piece of information. The three topics I want to cover today is one, some of the more common formulae that appear particularly in science but also in maths. Secondly, how to rearrange these formulae, particularly the ones that involve squares or one divided bys, and showing how to do that one line by line. And lastly, how to determine the gradient of a graph, and critically, how this relates to the actual equation that it came from, which is something which I do see some people struggle with, particularly at GCSE level. We're just going to jump right into it with some common formula in maths. So, one of the best things about maths is that things are always reliable and you'll always see the same equations. So, if you can have the time to memorize these things, they'll always serve you well no matter what you're doing. The first thing I want to discuss are some common areas and volumes. Now, a length is something which is just measured as a line. Okay, so it's just something like this, and that line is going to have a particular distance. In this example, we're just going to call it A. Okay, if you want to turn this into an area, that means you're fundamentally changing it into a two-dimensional shape, which means that it's going to turn into something like this. We'll call this length here B, and if you want to find out what this area is, it's going to be the two of them multiplied together. Quickly drawing this out, just to complete it, if we make this into, say, a rectangle, then that means that we're going to be having this here, and the total area is going to be AB. Okay? I've discussed this before in a previous video, but we're actually going to try and abstract it a bit now, because although this is simple for a rectangle, for all shapes, what you generally see is that if you want a length, it's always just going to be one measurement of length, which makes sense, so some kind of ranging with x, where x is a value measured in meters. Area is always going to be something like x squared, because you've got two lengths multiplying by one another. And then if we have something like, say, volume, that's just a case of then making this a little bit bigger on the z-axis, and that's what introduces us to this idea of this being a volume. And the volume of this entire thing would be ABC, if we keep the pattern. But that means that the volume of a shape is given as some kind of x cubed. And we see that for all kinds of shapes. The two most common shapes that we deal with in maths are a cube and a cube. For a cube, we're going to have a length, which I'm going to put in air quotes, which is like how long the side is. And we're going to call it r instead of x, because that's a word that we can use sometimes for the radius and things like that. So r appears a fair bit when doing lengths. Then the area of one face is going to be r squared. And then the volume is going to be r cubed. However, and this is why we call it a cube, in fact, because that's where we get the word for it from. And then if we then look to instead a sphere, so change my color here to a sphere. Instead, it's got a radius of r. Some of you might be wondering, actually, why we use radius instead of diameter. Quite a lot of the time whenever we're discussing circles, especially when we define pi as something which is relevant to the circumference and the diameter. The reason for that is because quite a few of the equations are nicely simplified when it comes to dealing with the radius of objects. Plus, it turns out that because the radius is halfway along something, if an object has some kind of symmetry, we'll often find that the radius is more useful for describing it than just saying half the diameter over and over again. Now, the surface area of a sphere is a really useful equation that you may not know, and that is equal to 4 pi r squared. Not necessarily obvious where that would come from. The pi is clearly related to the fact that this is something to do with a circle, but why 4 appears, I invite you to look up yourselves. And r squared appears because we're dealing with an area, which means we're going to be dealing with some kind of square. And then lastly, the volume of a sphere, something which is very common, is 4 divided by 3 times pi times r cubed. Spheres are very efficient ways of packing the volume of something such that you minimize the area. So they're very useful shapes in that regard, and that's the reason why we see so many things in nature having the shape of a sphere, because it allows something to try and minimize its shape as much as possible without having any lines jutting out. So the volume of a sphere appears a lot in physics, and I thought I'd just mention that here as a very useful formula to know. Next, for common formulae, is we've got distance, speed, acceleration. We mentioned distance a lot because obviously it's a distance gets used quite a lot in real life. So when we look at distance, we usually describe that as some kind of x sometimes, which is referring to a distance. Sometimes you might instead see it written as d for distance, or sometimes, confusingly, s for displacement, which is related to distance. Okay. We then have a few equations. So we say that distance is equal to speed divided by time. That was very wrong. We then see that speed is equal to distance divided by time. You can check the units for that by looking for things like miles per hour or meters per second. A speed is always defined as how much an object moves through an amount of space measured in meters in a particular amount of time, t. Then we have acceleration, which describes how much speed changes. So acceleration is equal to whatever the speed is divided by time. And that says how much that is going to change. Again, very common formulae. Lastly, we have this one here of energy. There's a few different formulae that we use for energy in science and in maths. So the first one we're interested in is kinetic energy, which is equal to half times mass times velocity squared. We've then got gravitational potential energy, which is all about gravity, which is equal to mass times the gravitational constant times height. And then we have work done, which equals force times a distance. These two equations are very similar to one another, but what we end up seeing is that we usually use work done when we're talking about going against air or things like that, or friction. So these are just some common equations I'd recommend you take a look at in your own time, and are certainly going to be useful for you going forward in both maths and science. Looking at how we then rearrange some of these very common formulae, it depends what you want to rearrange it for. So here's a very common equation, which is a modified form of speed equals distance divided by time, where we have acceleration on one side, and let's say we wanted to rearrange this equation in terms of acceleration. So to do that, whenever we rearrange a formula, it's like saying we want to get acceleration on its own. We want to say a is equal to something. So we've got to figure out how to get it on its own. Now, to do that, we're going to have to get a being alone on this side because we need to get rid of this t, but we can't yet divide everything by t because, as we know from BidMaths, we end up seeing division happens first. So that means that this u would also be divided by t. So what we're going to do is we're going to subtract u from both sides. So that means that we're going to have v minus u is equal to u plus at minus u. And that cancels these u's. Often, this little bit where you cancel is skipped. That's fine. If you feel comfortable enough to do it, that's great. But I know some students who'd rather have every step laid out. And if you're one of those students, that's absolutely fine. Then, now that we've got v minus u equals at, if we want to get t on its own, we have to divide both sides by t. So we get v minus u divided by t is equal to a t divided by t. T divided by t is going to give 1, as a very common result is anything divided by itself gives us 1. And we don't normally write 1 next to any mathematical formula we use, which means that we get the final result, acceleration, is equal to v minus u divided by t, which is actually another way of saying acceleration is equal to change in speed divided by time. So that shows how we might rearrange something that's a bit more simple. However, if we increase the complexity, we have something that looks like this. This is the equation for how long a pendulum takes to swing, and it only actually depends on the length of that particular swing. The rest of it is just constants. Let's say we wanted to rearrange in terms of L. There's a few steps that we could do to go first. However, again, with BidMaths, we begin with B and then I, which is indices. So we can't yet square everything. Otherwise, it would square everything on both sides as well. You can begin with that, but in general, it's good to try and get the square root on its own first. So the first thing I'm going to do is divide both sides by 2 pi. Now I'm just adding this little bit where I'm writing in what I'm doing here now, just to show you what you can also do if you feel like that would help you with your confidence. So we have t divided by 2 pi equals 2 pi over 2 pi root L over G. These 2 pi's cancel as before. And now we're going to square both sides. When you square both sides, everything needs to be squared. So that means that we're going to have, if we just put this sort of like square symbol here, we're going to have t squared divided by, and then it's 4 pi times 4 pi. Sorry, it's going to be 2 pi times 2 pi. So that means that we get 4 pi squared. That's going to equal the square root of L over G squared is L over G. Which means that lastly, if we want to get things in terms of the length L, we then have to multiply by G. So let's show that now by multiplying both sides by G. So that means that we get T squared G divided by 4 pi squared equals L. Okay? And that's how you could use this to determine the length of a pendulum. If you instead wanted to figure out what G was in this final step, I'll give you guys a second to think about what you'd have to do instead, because it's a little bit more involved. There's two ways that you can take. Either the first one is that we can multiply both sides by G, so we end up getting T squared G over 4 pi squared equals L, as before. And then we multiply by 4 pi squared, so we get that T squared G equals 4 pi squared L, and then we divide by T squared. So we get that G is equal to 4 pi squared L over T squared. So that's one way that we could potentially do this using the similar techniques we've done so far. Alternatively, we can take a bit of a shortcut, but only if you feel comfortable enough to do this. What we could also have done is, to get G on its own, we could also have turned it into 1 divided by G. So when we do that, we divide both sides by L, and that means that we get T squared over 4 pi squared L equals 1 divided by G. Now, 1 divided by G equals T squared divided by 4 pi squared L. So we can essentially flip both fractions. And that means that we get 4 pi squared L over T squared equals G over 1. And anything divided by 1 is just itself. So these are two ways that you could simplify these more complicated pieces of information. As a last one, which I'm going to leave for you guys to do, is we've got this somewhat unassuming formula down here, which is density is equal to mass divided by volume. But in this case, we're going to combine our skills from both places. What I want you to do is, if we say we have the volume of a sphere, which is 4 divided by 3 pi r cubed, rearrange this equation for the density of a sphere and try and get r as the subject. So rearrange and do as best you can there. That's about all the time that we've got for, guys, so hopefully you've learned a lot more about how to rearrange formulae as best you can, and also some of the skills that will help you in science and maths. Take care, and I'll speak to you next time.